Uh, good afternoon, everyone. This is my second video on the topic adjoint and inverse of the matrix. Yesterday, I have gone through the theory part of this chapter, a very small chapter of R.S. Agarwal, and tomorrow I am going to deal with the three questions of the this chapter from the R.S. Agarwal itself. So, the first question is. If A is equal to 1, minus 1, 1, 2, minus 1, 0, 1, 0, 0, then prove that A inverse is equal to A square. A inverse is equal to A square. Solution. See, in order to prove A inverse is equal to A square, we can prove that A into A square is equal to identity matrix by the definition of invertible matrix. Directly we are using the concept of definition of invertible matrix. So first of all, we have to find A square. A square is equal to A into A, or this can be, I think, 1, minus 1, 1, 2, minus 1, 0, 1, 0, 0, 1, minus 1, 1, 2, minus 1, 0, 1, 0, 0. I already assumed that you know the multiplication of matrix. Multiplication of matrix has happened only when column of first matrix is equal to row of second matrix. That is because both matrices are 3 by 3 square matrix, so the condition is satisfied. And if you've gone through the multiplication, we can obtain as 0, 0, 1, 0, minus 1, 2, 1, minus 1, 1. This is the value of A square. Okay. Now, if I multiplied A with A square, then what we are getting? So the value of A is 1, 2, 1, minus 1, 0, 1, 0, 0. And the value of A square that I will obtain already, 0, 0, 1, 0, minus 1, 2, 1, minus 1, 1. In this way, you can see the value of this is 1, 0, 0, 0, 1, 0, 0, 0, 1. So the product is obtained as identity matrix. So we can confidently say that A inverse is equal to A square. This is the first method. This is first method, or you can say this is the first approach by which you are applying for find the or prove that A into A square is equal to Y. What is the second method? In second method, what we have to do, we have to find A inverse by adjoint method. We have to find A inverse by adjoint method. So what is the value of A? A is 1, minus 1, 1, 2, minus 1, 0, 1, 0, 0. So first of all, we have to find that value of determinant which is obtained as 1, not equal to 0. Therefore, A inverse exists. If A inverse exists, then we can find the value of now cofactors. So C11 is equal to 0, C12 is equal to 0, C13 is equal to 1, C21 is equal to 0, C22 is equal to -1, C23 is equal to minus 1, C31 is equal to 1, C32 is equal to 2, and C33 is equal to 1. So how adjoint of matrix is found? So adjoint of matrix is found by taking transpose of cofactor of that matrix. So adjoint of A is equal to 0, 0, 1, 0, minus 1, minus 1, 1, 2, 1, 1, 2, 1, and take transpose of that. So we are getting 0, 0, 1, 0, minus 1, minus 1, 1, 2, 1. And in previous method you have seen that in previous method this is adjoint A. Now what is A inverse? How can you find A inverse by adjoint method? So we have a formula. A inverse is equal to adjoint A upon determinant A, or since determinant A is 1, so there is no change in adjoint A. So 0, 0, 1, 0, minus 1, 2, 1, minus 1, 1. And in previous method we can already found what is A square, which is exactly equal to A square. So therefore A inverse is equal to A square. This is the second method that I told that this is adjoint method approach, and previous is the concept of by using definition of invertible matrix. Okay. Now we have to move to second question. We have to move to second question now. The second question is so that A is equal to 1, 0, minus 2, minus 2, minus 1, 2, 3, 4, 1. Satisfy the equation AQ minus A square minus 3A minus I is equal to 0, and hence find A inverse. Okay, so this question consists of two parts. First of all, we have to prove that the value of this equation is equal to I0. That you already know in the chapter like multiplication of matrix, that we are already done this one, but also I am going to deal you or give you the solution here also. But this part I have already done in the previous exercises like multiplication of matrix. What is important here, why I am giving this question? Because of this one, hence find A inverse. Means we have to find the A inverse by using this equation only. We cannot find the A inverse by using row operation method, by using adjoint method. No. We can find A inverse here by using this equation only. So solution. So solution. Okay, first of all, what is the value of 3A? This is just 3 into 1, 0, minus 2, minus 2, minus 1, 2, 3, 4, 1. This is, I think, 3, 0, minus 6, minus 6, minus 3, 6, 9, 12, 3. What is the value of A square here? A square is equal to A into A, or 1 0 minus 2 minus 2 minus 1 2 3 4 1 1 0 minus 2 minus 2 minus 1 2 3 4 1, and after multiplication you got minus 5 minus 8 minus 4 6 9 4 minus 2 0 3. This is the value of a square. Similarly, you can find AQ. AQ must be written as a square into a, and if you perform a square into a, so then you are able to get AQ minus 5 minus 8 minus 4 6 9 4 minus 2 0 3 1 0 minus 2 minus 2 minus 1 2 3 4 1, and after multiplication these two, the value of AQ is equal to minus 1 minus 8 minus 10 0 7 10 7 12 7. This is the value of AQ. This is the value of AQ. Now, put the value of 3a, a square, AQ and I in the given equation. Now, AQ minus a square minus 3a minus I is equal to, put minus 1 minus 8 minus 10 0 7 10 7 12 7 minus a square minus 5 minus 8 minus 4 6 9 4 minus 2 0 3 minus 3 0 minus 6 3 minus 6 9 12 3. So in continuation, we've seen that the value of this matrix polynomial is obtained as 0. So first part we have proved. Now, how to find the A inverse? Come with the second part of the question, how to find the A inverse. To find A inverse, given equation is AQ minus A square minus 3A minus I is equal to 0 matrix. Multiply A inverse both sides. This is left multiplication. So this is A inverse A square minus A inverse A minus 3A inverse A minus A inverse I minus A inverse I is equal to 0. So as we know, this becomes I into A square, I into A minus 3I minus A inverse is equal to 0, or A square minus A minus 3I is equal to A inverse. This is the value of A inverse, and by putting the value of A square, A and 3I, we can easily get A inverse. So by using this equation, we have to only find the A inverse. And if you put the value, then A inverse is equal to minus 5 minus 8 minus 4 6 9 4 minus 2 0 3. This is the value of a square minus a 1 0 minus 2 minus 2 minus 1 2 3 4 1. This is the value of a and this is the value of 3i. This is the value of 3. So finally we are getting the value of A inverse as minus 9 minus 8 minus 2 8 7 2 minus 5 minus 4 minus 1. This is the value of A inverse. So this is the completion of second question. Now come to the third question. I think you all understand. For every question, the approach is, first of all, you must understand that how you can move through the solution of the question. If it is clear, then everything is clear. First of all, think, then you act accordingly. Now, question number third. Obtain inverse of matrix A is equal to 1 P 0 0 1 P 0 0 1 and B is equal to 1 0 0 Q 1 0 0 Q 1 and hence find inverse of matrix inverse of the matrix 1 plus PQ P 0 Q 1 plus PQ P 0 Q 1. So solution. So in this question also the word hence is here. So it means first of all we find A inverse, B inverse, then we can think about how can you find this matrix. But actually this matrix is nothing but AB. If you multiply A with B, then you can get same matrix. 1 plus PQ P0 Q1 plus PQ P0 Q1. Same matrix, but it means what we have to find? We have to find AB inverse. And by reversal law, we know that AB inverse is equal to B inverse A inverse. So our objective is to find B inverse and A inverse and then multiply B inverse A inverse to get AB inverse. This is the motto of this solution. So now we move for finding A inverse. So for the matrix A, determinant A is equal to 1 1 minus 0 minus P 0 minus 0 plus 0 into something, then this is 1, which is not equal to 0. Therefore A inverse exists. A inverse exists. And if I find the cofactors, C11 it is 1, C12 is 0, C13 is 0, C21 minus P, C22 1, C23 0, C31 P square, C32 minus P, C33 is equal to 1. So adjoint A, you all know, it can be written as 1 0 0 minus P1 0 P square minus P1. It's transpose. It's transpose. So this can be written as 1 0 0 minus P1 0 P square minus P1. And since determinant A is equal to 1, therefore A inverse is equal to adjoint A itself, as determinant A is equal to 1. So the value of A inverse is 1 minus P square 0 1 minus P 0 0 1. This is the value of A inverse. Again, I am assuming that you guys knowing how to find the cofactor of a matrix. If you don't know, you can comment, I make you understand. Now for B inverse. How to find B inverse? First of all, we can find determinant of B. So determinant of B is 1 0 minus 0, not 0 minus 0, 1 1 minus 0, then this is 0 and it is also 0. So it is 1 which is not equal to 0, therefore B inverse exists. B inverse exists. Now let us come to find the cofactor of matrix B. So cofactor of matrix B is equal to C11 is equal to 1, C12 is equal to minus Q, C13 is equal to Q square, C21 is equal to 0, C22 is equal to 1, C23 is equal to minus Q, C31 is equal to 0, C32 is equal to 0, C33 is equal to 1. Therefore, adjoint B is equal to 1 minus Q, Q square 0 1 minus Q 0 0 1. And its transpose. So it is equal to 1 minus Q, Q square 0 1 minus Q 0 0 1. And this is equal to A inverse. This is equal to B inverse, as determinant B is equal to 1. Now B inverse into A inverse. To put the value of B inverse and A inverse, you can get AB inverse, which is equal to AB inverse is equal to 1 0 0 minus Q1 0 Q square minus Q1 into 1 minus P square 0 1 minus P 0 0 1, which is equal to 1 minus P square minus Q PQ plus 1 minus Q P square minus P, then Q square minus PQ square minus Q P square Q square plus PQ plus 1. This is all about today's class, today's lecture. We have gone through the three important questions of this chapter, and later on we can move to the chapter known as system of linear equation in 3 variables, and we have to solve those 3 variables by matrix method. So thank you everyone, thanks for watching, thank you.